G. Elliott Hydraulic and Mechanical Engineering provide fluid power training for you. Hydraulic systems. A hydraulic system is an energy conversion device. It can be divided into three main segments. Power supply. This comprises of a prime mover and a hydraulic pump. Control. The control of three functions related to the fluid: pressure, direction, and flow. Output. Means are provided to convert fluid power into mechanical energy using a linear or rotary actuator. The mechanical energy provided by the actuator enables a load to be moved. Power supply. Some type of mechanical device is physically connected to the pump and causes it to move. This device is called a prime mover. If the hydraulic system is stationary, such as in an industrial application, the prime mover is usually an electric motor. If the hydraulic system is mobile, its prime mover is usually a petrol or diesel engine. Part of the power supply is the pump. Its function is to provide a flow of fluid through the hydraulic system. Depending on what type of pump is used, the pump moves in a rotary or linear fashion to discharge the fluid. The illustration shows a rotary pump. In a linear piston pump, the pistons move in a linear fashion against a swash plate. As the pistons move back, a partial vacuum is created and fluid is drawn in. As the swash plate forces the pistons back in, fluid is forced out of the pump and into the system. Another device which is able to provide pressurized fluid is an accumulator. An accumulator temporarily stores fluid in a hydraulic system. It releases the fluid when the system pressure is reduced. Accumulators are charged with pressurized nitrogen. Control. The control segment is located between the pump and the actuator, or actuators. This part of the system provides components with a controlling function on the fluid, and comprises the following: pressure, direction, and flow. Pressure control. One type of control that is needed is limiting the maximum pressure within the system. A pressure relief valve performs this function. This is the schematic symbol of a pressure relief valve. The pressure relief valve should be set to operate at a pressure 10 to 15% higher than the maximum working pressure within the system, into which it is fitted. Whenever a relief valve is operated, heat will be generated. The system should only require the relief valve to operate to protect the system and components within the system. When the piston rod is fully extended, the pressure increases to the setting of the pressure relief valve. The pressure has to overcome the spring pressure within the valve, and oil is allowed to pass directly back to the tank. If there is no designated way to limit the pressure, a catastrophic failure would occur to a component, seal, pipe, or hose. Without a pressure relief valve, the pressure created is unlimited. Direction control. Another type of control is to control the direction of rotation of a hydraulic motor, or the direction of movement of a hydraulic cylinder. This is the schematic symbol for a direction control valve. In this example, the direction control valve is used to extend and retract a piston rod. With the direction control valve in the position shown, flow from the pump passes through the direction control valve to the full bore side of the cylinder, causing the piston rod to extend. With the direction control valve in the position shown, flow from the pump passes through the direction control valve to the annulus side of the cylinder, causing the piston rod to retract. Flow control. A flow control valve limits the amount of fluid that flows to the actuator. This enables the speed of the actuator to be varied. If the flow control valve reduces the flow to less than that being supplied by a fixed displacement pump, the excess fluid normally passes over the pressure relief valve. As previously stated, whenever oil passes over the pressure relief valve, heat is generated. This is the schematic symbol for a flow control valve. A way in which a flow control valve is used is to control the speed of a hydraulic motor. With the valve fully open, the full pump supply is able to pass to the hydraulic motor, and it is able to run at its maximum speed. If the valve is slightly closed, the full pump supply is unable to pass to the hydraulic motor, its speed is reduced. The excess flow has to pass through the pressure relief valve. If the valve is fully closed, none of the pump supply is able to pass to the hydraulic motor, and the motor shaft stops rotating. All of the flow from the pump has to pass through the pressure relief valve. Output. The output segment is the part of the system that performs some kind of work. This type of device is called an actuator. The motion produced can be rotary using a hydraulic motor. The motion produced can also be linear, using a hydraulic cylinder. The actuator converts fluid power into mechanical energy to move a load. Hoses and pipes. Hoses and pipes connect the components throughout the hydraulic system. These hoses and pipes confine the hydraulic fluid in a pressurized condition and transmit power from one location to another.